Hi, I'm Mark Reeves. Welcome to this edition of News at National. As design engineers, many of you face challenges on a daily basis, like how to optimize system efficiency and deliver robust system performance, often in a small footprint and with minimal cooling requirements. These challenges come up in many applications, but especially when you're designing communications infrastructure solutions for wireless base stations and wired data centers. In the receive side of a base station, you face challenges all along the signal path, designing with amplifiers for signal conditioning, timing products for frequency translation and clock generation, ADCs for data conversion, and power supplies to power the signal path and digital systems. To help you meet these design challenges, National Semiconductor is offering a broad portfolio of devices that allow you to develop performance and power optimized solutions for multi-carrier, multi-standard base stations. Today, we want to focus on the new ADC 16V130, a high-speed ADC capable of converting analog input signals into 16-bit digital words at conversion rates up to 130 megasamples per second. The ADC 16V130 is the first 16-bit ADC to enable high IF sampling multi-carrier GSM receivers with high IFs up to 200 MHz. Higher IFs can simplify receiver design by allowing more flexible frequency planning and reduced filtering requirements. The 16-bit resolution provides you with the industry's best performance, 90.6 dBFS spurious-free dynamic range for a 160 MHz input frequency, and National guarantees 87 dBFS SFDR at 160 MHz by individually testing each component. With the industry's largest input bandwidth, the ADC 16V130 allows for multiple frequency plans, making it easier to design solutions for multi-standard, multi-carrier base stations. The 130 megasample per second ADC provides unequaled high-order harmonic distortion performance at any input frequency, while consuming just 755 milliwatts. In fact, the ADC 16V130 offers you performance to power metrics that position it within National's PowerWise family of energy-efficient products. Let me show you how well this ADC can work for you. Here on the bench, we have an ADC 16V130 evaluation board connected to a WaveVision data capture board, which is hooked up to a laptop through a USB port. There are two frequency synthesizers, one for the clock and one for the input signal. Both signals must be filtered to measure the true ADC performance. The clock amplitude is set to 18 dBm to minimize jitter. The 160 MHz input frequency is set for a -1 dBFS output from the ADC. Now we use the WaveVision software to capture 32K samples and perform an FFT. As you can see, the FFT shows the performance for 130 megasamples with a 160 MHz input at -1 dBFS. There is no other part in the market that can match the ADC 16V130's performance for inputs of 160 MHz and above. The ADC 16V130 can be combined with National's LMH6517 digitally controlled VGA and the LMK04000 low noise clock jitter cleaner to create a complete IF sampling receiver subsystem. We also provide the SP16V130 CH4 reference board and design collateral to reduce your time to market. This board includes the ADC 16V130 and the LMK04000 in an optimized configuration. So, as you can see, National Semiconductor is helping to make your design process easier for communications infrastructure designs. And the ADC 16V130 also works well in system designs for medical imaging and test and measurement solutions. You can get all of the details on National's latest data conversion solutions at national.com/ADC. And to see all of National's products, tools, and resources for communications infrastructure, visit national.com/comms. And you'll find much more information among the links here in this newsletter. That's all for this edition of News at National. Thanks for watching. We'll see you again next time.